Hi chemistry students, Miss Vannoni here. So as we continue in chapter 2 talking about measurements and calculations, we're going to pause for a quick moment and talk about density. Okay, so that's going to be the second of a couple of videos that we're going to see in chapter 2. So density is going to be the relationship between mass, okay, and volume. All right, so mass being the amount of stuff that something has, okay, and volume being the amount of space. So we're looking at the relationship between these two pieces of information. So when we think about density and density calculations, again, it's the amount of matter or stuff that something has per the amount of space that that thing takes up. This is an intensive property. So if we think back to chapter 1, we talked about matter and changes. An intensive property, it's something that never changes no matter how much of something you have. So the ratio between mass and volume for a given substance is always going to remain the same no matter how much mass or how much volume that particular thing has. Okay, the relationship will always continue to be the same regardless of what the amounts are. Okay, you also want to keep in mind that we're going to have a two-dimensional unit. We're either going to be grams per milliliter if we're talking about a volume that's a liquid, okay, or grams per centimeter cubed if we're talking about a volume that's a solid, okay, so think like a cube versus something that you'll measure in a graduated cylinder. Okay, it could also be a variety of forms of those things, like kilograms per liter, milligrams per milliliter, any sort of those. And we'll talk about conversions at another time. But again, they're always going to be the ones that we're most likely to use are grams per milliliter, grams per centimeter cubed. Okay, so if we look further at the density relation, if we go back here and look at this practice problem, a metal block has a mass of 45.62 grams and a volume of 50 milliliters. What is its density? So the two pieces of information that are important here are the mass of 45.62 grams and the volume of 50 milliliters. So if we want to know the density, let's see how that plays out on the next slide. Okay. So again, we want to keep in mind that the relationship for density is going to be the amount of mass per space. Okay, so it's a direct relationship. So we're going to put our grams over our milliliters, and we're going to divide, and our answer is going to have 4 sig figs. You always want to keep in mind sig figs, okay? Never ever forget. We're going to use them from here on out, okay? And you're going to see that my answer has 4 because each of my values that I'm calculating with has 4. You always want to remember your unit. If you don't have a number and a unit, you have an incomplete answer, okay? So a fun way that I like to remember density is going to equal heart, right? So if you look at this closely, it's M over V. All right, so we're going to keep that in mind as we do a couple more problems. So let's look at another calculation here. The density of gold is 19.3 grams per milliliter, and a sample has a volume of 100 milliliters. What's its mass? Okay, so if we keep in mind again, density equals mass over volume. We know if it helps to break it out like this, you can do that. We know our density is 19.3 grams per milliliter. We know that we're looking for mass, and my volume is 100 milliliters. So if I set this up, I have 19.3 grams over milliliters equals x over 100 milliliters, and then I can solve. Or what I can do is manipulate my density equals mass over volume to start, so I don't have to do any funky math. So if I know that density equals mass over volume, and I want to isolate the variable that I am looking for, which in this case is mass, I can multiply both sides by the volume. So what I would do is multiply by the volume on both sides, right? Because it's like multiplying by volume over 1. So density times volume is going to equal mass, and then I could plug in my numbers from there, right? Oops, sorry, let's make this another size. So I would have 19.3 grams per milliliter times 100 milliliters. And then my milliliters units would cancel because one is on the top of the fraction, one's on the bottom, leaving me with grams, and I could solve. Okay? So, what you can see here is my mass. If I do out all my calculations, and you can see here how it was manipulated, right, like we did on the previous slide, you can see that your answer comes out to 1930 grams. So your answer actually has 3 sig figs because that final 0 right here is not significant. Another way that you could look at this is if you have a density of table salt is 2.16 grams per milliliter, and the sample of table salt has a mass of 22.81, what must its volume be? So again, if density equals mass over volume, you could plug in that way. Equals 22.81 grams over x, or you could take this right here and isolate your volume, right? So density over mass would equal volume. Sorry, I had that backwards. It would actually be mass over density, right? I'm sorry about that. Let's get rid of that and get the correct one in there. Mass over density. Okay, and if you solve it all through, you come out with an answer here. Again, 3 sig figs because this number right here has 3 significant figures. Okay, things we want to keep in mind when we're talking about density: substances that are less dense are going to float over things that are more dense. You want to think ice. If you think back to biology, you want to think ice cube versus liquid water. Those bonds are spreading apart and separating in that ice, making it less dense than water, even though they're made of the same substances. And substances that are more dense will sink. Again, if you think about the ice cube sinking in the rubbing alcohol, because of the differences in the densities there. So if you have more questions, be sure to reach out, and hopefully you found this quick little video about density helpful.